Hi everyone. Today we're going to talk about the intelligence explosion. This idea that the rate of AI improvement, as fast and steady as it is today, could become way faster. The intelligence explosion is a rate of improvement of AI that's completely out of control, where AI improves itself. And I have gathered a couple of arguments today why I believe that it will happen. There's a bunch of con arguments. We're going to go through them another day, but first I'd like to talk to you about why I believe that FOOM, aka the intelligence explosion, is very likely. I like to illustrate the intelligence explosion as something akin to a rocket that leaves the ground and it races through the atmosphere, and most of its fuel is burned in the first 90% until it reaches the edge of the atmosphere, and then it becomes way easier to accelerate on. Or, for example, take a microphone feedback, where you put the microphone too close to the loudspeaker, and as you put them closer and closer, there comes a point where this deafening noise is just gonna blow out the whole amplifier. Or think of, for example, a fire burning with logs of wood that you put on. You're putting more and more firewood on it, and it burns bigger and bigger. But when you switch from firewood to gasoline, that is the intelligence explosion. So I'd like to invite you to follow me on exploring why I believe that the intelligence explosion is likely to occur. This table shows you a couple of different things. The score is what we're interested in. This is how much I think that each argument is relevant. And I multiply the probability with the weight scores to get the final score. Some arguments are more important and weigh more in why the intelligence explosion will occur, but some are more or less likely to contribute to that happening. So let's dig in. First up, we got recursive self-improvement. This is the idea that as AI gets better at improving itself, the rate of its own improvement will get higher. Picture this: a student who not only learns subjects at the university, but also invents better learning techniques, accelerating his own education process. Think of ChatGPT-4 helping AI engineers today to work faster and come up with better ideas about how to make ChatGPT-5 better, right? But taken to its extreme, imagine an LLM, imagine an AI that could overtake all of the job of those people who develop the next better, faster, smarter versions. Next up, we got new machine learning paradigms. This is the idea that there's a holy grail of machine learning. Think of it like a better, more efficient way to train and run these models. It's something like a sudden big leap in how AI learns. Because today, AIs don't learn efficiently. AIs need a lot of data and a lot of compute to become as efficient and as smart as they are. But a lot of very smart people are spending a lot of time on developing new architectures, new paradigms. The current paradigm being LLMs, large language models like ChatGPT and Google Gemini, which are producing word by word an answer to your query. Maybe a different paradigm, a different way of coming up with answers, a different way of reasoning could result in these models not needing as much data and not needing as much time within a computer to get to the level where they are today. If that were to occur, I give it a low probability, but if that were to occur, that could propel us overnight to something like 1000x efficiency boost, and that would be the intelligence explosion itself. Next up, number 3 here, we got reinforcement learning by self-play and self-teach with synthetic data. So this is the idea that AI learns by playing against itself using made-up scenarios. Think of something like a tennis player who can create and play against infinite versions of himself, thereby rapidly improving without a human coach. The best way to improve is to have the best teacher. And if AI itself could become the best teacher of AI itself, then it could lead to way faster improvement of the AI itself. I give it a high weight and also a high probability because people are working on this today, and they all know that some version of this reinforcement learning will have to be implemented to be able to train systems that are better than humans. Today, most of the training, most of the reinforcement learning is done by humans, but imagine a future where AIs take that role, and there could be millions of those AI teachers, simultaneously teaching their cousins how to get better at coding, reasoning, math, and love. Next up, we got the compute overhangs. Compute overhangs is the concept that there's a sudden unlock of hidden computer power. We use a lot of computing power today to crunch out the next ChatGPT. But we also know that there's a balance between how much computing power you put into training the models and running them. There's the so-called test time compute overhang, but there's also the compute overhang in the sense of as soon as you have a very capable AI, something like a virtual AI engineer, a virtual software developer, you will not have one of them. You will have 1 million or something up to 100 million at the same time. Next up, number 5 here, we got productivity increase in AI research. The idea here is that you have AI engineers today, people who develop ChatGPT and Claude and Gemini. Those are very, very smart people. It's a high bar. And instead of reaching that bar and having ChatGPT do all the work, like we saw in the first argument here, recursive self-improvement, this is a lighter version of that, which will probably happen way before we reach an automated virtual AI engineer. Think of the pace of AI research being bottlenecked by how much those very top AI engineers could do in one day. And if you could increase their productivity, if you could make their work 2, 3, 5 times better because AI helps them, then that could constitute a very fast improvement in the next generation of AI systems. I think it is very likely, and it's in fact already the case today. Today's AI engineers are already using AI and will continue to do more and more. And so that is going to be the ramp, if you will, to the intelligence explosion. Imagine robots that not only work in a factory but also design and build better robots, or a writer using an AI assistant that not only helps with current work but also improves itself to offer even better assistance for future projects. Increase in compute. That's an easy one. Computers get better and faster every year, hence the higher probability, and it is going to give the intelligence explosion a nice little background noise, a nice little background lift. In itself, the increase in compute will not lead to the intelligence explosion, but to reach the threshold where the explosion could indeed occur, we need ideally more and more compute. Picture upgrading from a pocket calculator to a warehouse full of supercomputers. That's what happens. It's basically a weightlifter suddenly gaining access to a futuristic strength-enhancing exoskeleton. Technically, what it means is the exponential growth in available computational power, including advancements in hardware architecture, quantum computing, and all that, crazy stuff. And it is certain that it's going to continue. Next up, the scaling laws. The scaling laws are laws that are empirical The scaling laws are about AI getting smarter as it's getting more data and computing power. We do not know, hence the low probability. We do not know if that will be the case in the future, that the scaling laws will help us. But I got a hunch that if not at the rate that we have been seeing so far, there's going to be some amount of improvement with each generation of large language models just by making them bigger, by throwing more compute and more data at them. Picture a farm that produces exponentially more crops as you increase its size and resources, and that's what we're doing. Like, we're making just a bigger farm with more seeds per square centimeter, and it just yields more and more crops. Or picture a library where each new book added makes all the other books easier to understand and use. Next up, we got growing context. That is the context window of AI systems. It is how long your question could be that you ask ChatGPT. Today, these are tens of thousands of words. You can ask ChatGPT a very, very, very long question. But if you want to upload books worth of data for ChatGPT to think about it and to combine them and to come up with something original about that input data, you need growing context windows. And it is happening today. We observe and we know that the leading AI companies are working on increasing the context window, hence the high probability 8 here. The weight of it is pretty low because I do believe that it will make AIs qualitatively different, but not at the scale of recursive self-improvement. The growing context is basically AI understanding bigger chunks of information at once. It's like a person evolving from understanding individual words to grasping entire books at a glance. Or it could be seen as a microscope that can zoom out to see an entire ecosystem while maintaining the detail of individual cells. Progress measured in benchmarks. How do we know that AI is getting better? And at which rate, right? People make benchmarks, and these benchmarks are math benchmarks, reasoning benchmarks. People make benchmarks to check how much they understand what the question was. All these benchmarks are showing that AI is getting better and better at reasoning, understanding math, science, coding. There are benchmarks that are trying to gauge AI at very broad tasks, like solving math puzzles or solving entire reasoning exercises. It's a quantifiable improvement in AI performance on a standardized test and task, providing concrete metrics for advancement across various domains of artificial intelligence. We know that they are getting better at every single benchmark in every single domain. Picture an athlete breaking world records in multiple sports simultaneously. Every month, there's a new world record. Or picture a student acing increasingly difficult exams from elementary to postdoctoral level in rapid succession. Q-star or System 2 thinking. It's a potential breakthrough in AI's ability to reason. Today, what large language models do is spitting out words. It's their stream of consciousness. It's their next thing that they can think of without thinking much about it. They're just blurting out words, and we know that we don't think like that. We think before we speak. And AIs could and should and are today learning to do System 2 thinking, which is called Q-star at OpenAI. It's a hypothetical AI system or approach that demonstrates advanced reasoning capabilities, potentially bridging the gap between narrow AI and more general intelligence. It is something like ChatGPT 01 or 01 preview. Imagine the leap from a simple calculator to a mathematical genius who can prove complex theorems, right? Or something like evolving from a GPS that can only follow roads to one that can creatively plot entirely new and optimal routes. New models keep surprising. In fact, we know that every time a new model came out, ChatGPT 3, ChatGPT 4, boom, they stunned everyone. It's the emergence of unforeseen capabilities and behaviors in new AI models, often exceeding the original design parameters and demonstrating potential for rapid, unpredictable advancements. We didn't know that these systems are going to work and come up with things that we have not programmed them to. Imagine planting a normal seed and growing a tree that produces different fruits on each branch, or a simple drawing program that spontaneously starts creating masterpiece paintings. And those were the reasons for an intelligence explosion occurring, a rapid improvement in AI capabilities where it's going like this today and tomorrow it could go boom. Stay tuned to find out why there could be some braking mechanisms, why there could be no intelligence explosion, why the FOOM could be a flop.